So as you can see, the battery has changed configuration. I was very much into the next video. I was hoping to have this battery set up, the BMS powered up, and I was going to start working on the main battery connections and connect it to the charger inverter. I thought, well, before I do this, I should really reread the manual one more time, and I am glad that I did. I had misconceptions about how something called top balancing worked and the importance of top balancing. Before I go much further, I need to explain what top balancing is so that the rest of this conversation makes sense. Top balancing is where you bring all of the cells in your battery to the same state of charge. You fully charge them up. They have all the same voltage. They have all the same amp hour capacity. They are full. They've all been charged to this exact same level. That's top balancing. Why is it important? So, I originally thought when I bought these batteries and bought this BMS that I didn't have to worry about top balancing. Bashen has a good reputation. They ship all of the batteries, in theory, at the same state of charge, and I would be able to just connect them up to the BMS, and the BMS itself has an ability to top balance. Specifically, I'm going to pause here for a second and step back briefly. Specifically, when it's charging up a battery bank, the first cell that hits the cutoff voltage, 3.65 volts, causes the BMS to shut down charging entirely. So I could have a whole series of cells at, say, 3.5 volts. One of them happens to be more full than the other, and it hits 3.65 volt first, and that stops the charging. Okay, great. You don't want to overcharge these things. That would be a very bad day. You would destroy the cell. So I thought, well, the BMS is going to handle this. And to a certain extent it can. Built into the BMS on each one of these lead pins is a little resistor. When one battery reaches top voltage first, 3.65 volts first, if the others are below that voltage, it can basically use the little resistor to convert some of the charge in the individual cell into heat, draining it down until it drops below a threshold and the charging can kick back in and bring the other cells up a little bit further. But this process of discharge, charge, discharge, charge, it only has a certain amount of capacity, and these battery cells have a phenomenal amount of battery capacity, of energy capacity. Realistically, the little resistor that's in here, it just can't do it if there's any kind of a big difference between any of these two cells. So, as I read the manual, I very quickly realized the manual for this thing is fantastic. The Overkill BMS manual is wonderful. They make absolutely no bones about how important it is to manually top balance first, with lots of examples as to why. Links to videos, links to pictures that other customers have sent in who made the mistake I was about to mistake, thinking, that's okay, the BMS will top balance it, I don't need to worry about it. Why is this an issue? Why is this a misconception? We already talked about how the resistor can only do a very limited amount of discharge of the energy relative to the total pack capacity. The trick is that if you wanted to check each individual cell to see how charged it is, the traditional way of doing it is you stick a multimeter on it and you see what the voltage is. And you look at the graph for what the voltage should be at various states of charge. What should the voltage be at 100% charge, 90% charge, 80, 70, 60, 50, 40, 30, 20, 10? I think I skipped one. Point is, you would see that it's actually very flat. Towards the full charge, the voltage spikes right at the very end. When you're discharging it, right at the very end, it falls off a cliff. But for the majority of the state of charge of these cells, the voltage is very consistent. So I could have one cell that is at, say, 40% state of charge. I could have another cell that's at 70% state of charge. A massive difference in actual energy stored in each of the two batteries. And the voltage difference would be tiny, measured in the millivolts. you can't use the voltage to determine how charged these things are, not reliably. So if I had just connected the BMS and thought, I'm just going to let it sit there until it top balances, it could take literally weeks. And even then, if one of the cells was particularly higher charged than the others or particularly lower charged than the others, it still wouldn't balance. The resistors in here used to deplete some of the charge in these cells is just not strong enough. You must top balance lithium iron phosphate before you build your battery. Okay, great. How do you do that? I didn't know until last night, because when I realized the mistake I was about to make, I had to do a lot of learning. This is both the frustration and the joy of being new to something. Okay, so I realized I needed something called a charger. I needed a benchtop power supply that could provide a consistent 3.65 volts, that accurate, and be able to provide a good amount of amperage. Because at 280 amp hours, if I'm providing 10 amps, if one of these cells was completely depleted, it would take 28 hours at 10 amps to charge one of these cells. I have 16 of these cells. So at 10 amp, I have 280 times 16 amp hours. If I can only provide 10 amps, which is already a lot, it's going to take a long time to top balance this. You need a relatively beefy charger, and you need one that can provide a very, very precise voltage. I look at some of the bench, what they call bench power supplies. I didn't know what this was before I started. They're very expensive. So I started looking for options, and I found in the quadcopter community, those drone copters that everyone has, they have a lot of resources about very accurate chargers for not too much money. And I found a particular type of charger called an iCharge X8, which I have just ordered. Should be here in 2 to 7 business days. I don't know if it'll be here next week or not in time, but it'll get here when it gets here. It is able to provide a very, very specific voltage, and I can use it to charge all of these batteries. I have a few ways of doing this. I could charge each individual cell, or I can take the cells. I'll turn this here. I've already turned one around. Before, when I had this set up as a battery, I wanted positive, negative, positive, negative, positive, negative, so I could create a series battery. What I'm going to do is take these, turn them, and I'm going to create a giant parallel battery, positive, 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 positive. When I connect these, the voltage on the battery, so right now I've got, if you ignore this, I've got 5 cells, let's say 4 cells because we like things in more even numbers. I can connect these 4 cells and it would be like a 3.2 volt battery that has 4 times 280 amp capacity. Totally reasonable. I'm going to connect all of these positives together, all of these negatives together, and then I'm going to connect up this new X8 charger, and I'm going to monitor with a clamp amp meter. You put that over the positive wire, and you just watch how many amps are being drawn. You watch it until the amperage drops off. If any one of these cells is not full, you'll see amperage on the display. So you leave the charger on there until the amperage drops to nearly 0. Then these 4 cells are charged. I do it again for the next 4, next 4, next 4. Once all of the batteries are fully charged, that is when this pack will be considered top balanced. And at that point in time, I will know that all of these cells are fully charged, have the same state of charge. Then I can connect the BMS. And then whatever little bits of drift there might be in these batteries, the BMS's onboard balancing will be able to handle it because the drift won't be too great, so that little resistor will be more than enough, generally speaking. If you have a bad cell, you have a bad cell. But generally speaking, assuming everything's operating, this will be able to keep everything balanced over time. But it is critical to do this initial top balancing. I nearly screwed it up by not understanding that. Again, read the fine manuals. The people who write them, they don't want their time wasted. If they're putting their time into writing documentation for you, there's generally a good reason for it. So that's where we stand at this point. I can't do anything more until I get the new charger. And then there's going to be, sneak peek, converting a server power supply to a really cheap, steady voltage for the charger that we've got coming. But more on that later. I'm the Digital Mermaid, and this is the process of learning. It can be frustrating, but it's always fun. Cheers.